Okay, so for today's class, we can have, I think, one or two examples how to solve the undetermined coefficient. Okay. So again, one more time, no class next week. So but it also depends. Okay, if you need to have, I can arrange, or maybe just additional video. Like I will upload some videos for the class. Okay, so you can just watch and basically no offline class. Okay, so still no class. Okay, so next week no class. Okay, to help the undetermined coefficient, actually there are some particular solutions that can be offered. Like for example, you can see that on the left side there are some functions that we can see. Well, first we can start from a constant, which we can apply our particular solution to be just another constant. I think this number one is clear, right? Number two, linear equations. The possible solution is also linear equation. And then you can see all kind of, at least we have polynomials, trigonometry, and the exponent. Okay, only three types. Whenever you see, for example, you see polynomials, you will suggest to write the particular solution as the same degree, polynomial the same degree, and our goal is to find all the coefficients. So you are going to have this, and then try to derive, and then put back into the equation, and then solve the linear equation. And then we have trigonometry, which we can see we need to have both cosine and sine, because they are going to have the same amount of or the same results if you derive. You have exponent, you need to also have an exponent, the same exponent. And then if you multiply, for example, multiply the linear with the exponent, it means that our solution also multiply the linear and the exponent. Okay. Same thing with the second one. And for the number 10, we are going to multiply all the trigonometry. So this cosine, so each one of them will be multiplied with the exponent. It's the same, just multiply all together. And if we multiply like the last one, we multiply the xe with 3x. It means that we have the cosine, okay, and then we have the x is we can think like a linear equation. So we need to multiply with this. Okay, so let's say, okay, we are going to have several components on the function of x on the right side. Let me give you a quick example. Suppose that we have this. Okay, suppose that we have this. This can be really annoying because it can be really long. This is just an example, okay? So first, start with the constant coefficient. We are going to solve the homogeneous. So we are start to write m squared. Just as usual, we solve these quadratic equations, I think we can find the solution. We can factor it easily, right? And we find that this m equals 7 and m equal 2. So we have our complementary. I will write 2 first, and then this 7. Actually, if you are maybe writing 7 versus, okay. Okay, so you have this. And remember, every particular solution, every suggestions that you offer, you need to make sure that they are linearly independent with the complementary. So if you have this e with power of 2x, e of power 7x, if you find maybe in the particular solution you find that you need to have like e with power of 7 or 2 or 2x, it means that you need to make that exponent linearly independent. And the easy way to get that linearly independent is multiply by x. But I think it's safe because we don't have the 6x, so I think it's already linearly independent. So I think it's safe. Okay, now we start to break down this function. So we have a polynomial, x squared, and we have trigonometry, we have x squared. So we have 3 different yp. Okay? So the polynomial, we can write yp1 like that, and then ax squared plus bx plus c. Okay. And then the second yp is the sine 2x. So we can write maybe d cosine 2x plus e sine 2x. And then the third one, you can write f x e 6x plus, because we are going to have another e to the 6x. Okay, so our yp is the combination of these 3. So we can write yp is ax squared plus bx plus c plus d cosine 2x plus e sine 2x plus fx e with power of 6x plus g e power of 6x. I don't think I would like to try to solve this, but this is just to give you an idea that our yp can be more than 1, so you need to combine all together. And then I will consider if this is going to be an exam because it's too long. If you can try to solve if you want, try to take derivative, second derivative, and then put back into the equations. And I believe it will be your paper will be full. Okay, just an example how to break down the structure. Okay. I think later I will put all the notes, especially for the higher order differential equations later on the Moodle, so you can check that out, including some of the exercise on this chapter, the undetermined coefficient, which you can also try after the class. Okay. So basically the key is first homogeneous, you solve, you get, and then try some suggestions for YP. Okay. And remember, the YP need to be linearly independent from the Ys. So if you find the same for the dependent, then you need to make it linearly independent. Okay. And then the rest is we are going to have some good algebra skills to solve the coefficient. Okay. But there are limitations within this method. If you see the table or the example that we did before, especially at the trigonometry, we didn't see any tangent, for example, or tangent or secant. Especially tangent, if we are thinking on tangent, if we take derivative several times, it doesn't have any diverge form, which means that we need to take another method. So every time you see the right side of the functions or the differential equations, if you see something like polynomial linear equation, exponent, sine or cosine, you could definitely use this method, the undetermined coefficient. But if you see, for example, tangent, then you cannot use this, because if you check the tangent, it checks possibility of its derivatives. The form will be expand, and I don't think it will be a good solution for that tangent. So the better idea is to have another method, okay, which I will give you some introduction. I hope I can give you the introduction. But before that, this is some example on the undetermined coefficient, which you can check later. So including all the some of the piecewise defined functions we also have. The principle is the same. You have the interval, okay? You have the interval, and then you need to make the solution continuous. Okay? Because for example, this is having the initial value 0, right? X equals 0, which means it's only for the first one. For the second one, you cannot exchange this one. Okay? So how you get this second solution is basically through continuity. You need to make the first interval by limit is the same value left hand, right hand, and equal its function itself when you plug in the value. Okay? So it's the same with your quiz, with your midterm exam, the same principle. But the way we solve this, we are going to solve with undetermined coefficient. Okay? So we have sine, so we are going to use the A sine and plus B cosine, and then find A and B, and you get the result. You get the first equations, and then after that, use the limit. Okay? So I hope you could try, especially for some combinations like this, EX cosine, or even the X squared sine, or maybe E and then the polynomial. You can try this one later after class. Okay? At least try 3 different examples and make sure you can identify how to write the YP, okay? Because that's the key. We know the YP, and then that will be we can find the solutions. Okay. So that's a brief example on some questions. I took it from the textbook. Okay, so I will start a new method which we call the variation of parameter. So to start this, we can consider this example like I mentioned before. Let's say we have a second order and we have a tangent on the right side. If we can write, let's say, function h is tangent x. So let's say we derive this several times. We derive and then derive. Right? To secant tangent, right? Yeah. And then from here you will get product rule, which you are going to have more expansion. So since this is going to be larger and larger, then we need to have another method. So to find yp, so to find yp, then we need to rewrite yp as we need to introduce another function. Let's say u. So let's let u is a function u1 y1 plus u2 y2. So it's pretty similar to the substitutions that you have had before. Okay. And then from here, similar to what we've done before, we try to derive several times until we get the second derivative. So let's say we have u1 prime y1 plus u1 y1 prime plus u2 prime y2 plus u2 y2 prime. Okay, I hope you don't get confused about on the prime, which means the derivative from the product rule. I will combine this and this. Okay. So yp prime Okay, and then we have another second derivative. So u1 y1 double prime maybe let me write this first to give you clear. Let me write here, maybe on this one I will directly derive from the first one. So that, and then we have y1 prime u1 prime plus y1 u1 double prime y1 u1 double prime plus u1 prime and then plus u2 y2 double prime plus y2 u2. Oh, I need to write one more. Y2 prime or y2 prime. plus y2 u2 double prime plus u2 prime y2 prime. Okay, suppose that I haven't give you the. So suppose that we have the standard form, which is y double prime plus p of x y prime plus, I forgot to write this. Okay, now we have this. So we are going to substitute all y prime and y double prime to the equations. So I will write, I hope the space is enough. Oh, this is y p. We substitute, right? We substitute. So u1, we're going to take all u1 from the second derivative, which is y1 double prime plus u1 from here is p y1 prime plus q y1, and then plus u2, red with blue. u2 is from the y double prime will be this y2 plus, where is y2 is there, py2, oh, wrong one, not this one, supposed to be this one, y2 prime plus q y2, okay. And then plus the rest of it. I think I can write here plus y1 u1 double prime plus, let me write this one, plus u1 prime y1 prime plus it's a little bit long, but the conclusion will, I think, not this long, okay? Plus p, the rest of the y prime will be y1 u1 prime plus y2 u2 prime, and then the constant at the end is plus y1 prime u1 prime plus y2 prime u2 prime. Okay, now this part here, the y double prime plus by prime and q y1, and this one here, this is supposed to be 0. The same reason when we had the previous sections. which we have the second order and then homogeneous, that will be 0. So then we can focus on the rest of it, which we can somehow simplify the product form from this and then from this. Okay, so the rest of it is actually this, and the plus b, this one, y1 u1 prime plus y2 u2 prime, and then plus y1 prime u1 prime plus y2 prime u2 prime. Okay, we can combine the product form. So combine, just adding as usual. And then let me write with different color to see the different component. And then plus so what should we try to make this solvable? So to make this, or to find the solutions, we can approach, so assumption to solve differential equation is that the function u1 and u2 need to satisfy that the whole y1 u1 prime plus y2 u2 prime is equal 0. When it's equal 0, it seems that we might have a chance to solve. And also, and it is reduces the y1 u1 prime plus y2 prime u2 prime equal a function of x. So as long as we can determine our function that can be satisfied with these two equations, so let me write in more clear way. So solution of system So solution of the system can be expressed in determinants using Cramer's rule. Which is u1 prime is equal w1 over w. W is the determinants. I will explain later. this is equal to negative y2 f of x over w, and then u2 prime is w2 where the w is this determinant of only y, y1, y2, y1 w prime, y2. And w1 is so anyone know Cramer's rule in matrix? Or no, not remember. So Cramer's rule basically, so we usually write in terms of matrix. So this is, so suppose the y is the coefficient. Okay? Because we want to find this one, right? So we can take this as a variable. So the Cramer's rule basically, so Cramer's rule is basically we are going to take division between determinants. The first determinants, let's say the w is all these terms, coefficient put here, okay? And the w1, basically the first, column, change to the right side, okay? And if you have w2, which means the second column change to this one. Okay? So that's why we have the negative, because it's going to be having 0. So we have 0 and f of x, and then y2, and then y2 prime. And then w2 is y1, y1 prime, and then 0, and then f of x. Okay. So from this determinant, we get the u1 prime and u2 prime. And then we integrate to find u1 and u2. And w basically you can also remember as we did in the reduction of order in the Wronskian, the same thing. But this is the Cramer's rule. Okay, this one is Cramer's rule. Cramer's rule basically you have a two linear equation, or you can have a system of equations. You put all in terms of the matrices, and then you find the determinants. So you find the determinants of the coefficient on the left side, and then you find each one determinants. Changing the first column, you get the determinants. Changing the second column, you get the determinants, and then divide with the determinants on the system of equation. Okay, that's the Cramer's rule. I don't know, do you get Cramer's rule before? Or no? No? Okay. Then just looking at this. The W means it's Wronskian. W1 means Wronskian, but change the first column to the right side of the equation. W2 means you change the second column to the right side of the equation. So that the W1 is the original one. It means that all the coefficients standard, this one, okay. W1, changing the first column to this, okay. And W2, changing the second column to the right one. So start from the original one, and then W1, W2. The U1 prime and U2 prime basically divided W1 divided by W, W2 divided by W. And W you can think like it's a Wronskian, the one we did before, the Wronskian. So it actually can be applied for higher, like more than 2, like 3 by 3, 4 by 4, but actually it will be very messy on this matrix. So it's not a good idea to memorize the formula. But as long as you can do the Cramer's rule, from the equation, I think it should be okay. So at the end of the day, our particle solutions is where is the, I write somewhere here. Yeah, our particle solution is this. Okay. At the end of the day, our particle solution is this. So our idea that the Cramer's rule had here is basically finding the U1 and U2 from the U1 prime and U2 prime. After we get this, we integrate and then put back into the first suggestions. Yp U1 Y1 plus U2 Y2. How do we get Y1 and Y2? Oh, that's a good question. We get Y1 and Y2 from the complementary functions. Okay, so start with homogeneous equations. You get the complementary. You get C something something plus C2 something something. That something something is actually, we can think that will be our best way to approach Y1 and Y2 to be put inside this one sphere. Okay. Okay, maybe to get a good example, maybe have to, some examples. Okay, how to sort of use these solutions. Okay. Let me write here, Y1 and Y2. From YC form. So actually, this variation of parameters, it could works for most cases. Like the one that we did before, we can actually try using this one. But sometimes maybe like one method will be preferable than the other method. Like the previous one, we have some limitations, especially for tangent or something like that. Then you need to use, I think, this method, variation in parameters. Okay, I think I can give you some example. But if I don't have time, maybe just maybe additional video later on. But anyway, because it's around 10 minutes more, maybe I will give you the score first. I haven't differentiate the local student and the international, so I'll put into 2, but it's actually mixed, so you need to look one by one. You can check.